Use integration by parts to find x sine 3x integrated. Okay, so this is our integration by parts formula. We have u dv over dx integrated is equal to uv minus v du over dx integrated. So what we're going to need to find is our u, our v, and our du dx. So we can set our u as x and our dv as sine 3x dx. And then our du is equal to dx. This is because x differentiated is just 1. So then if this is du over dx and this is 1, then you just multiply by dx on both sides and you get du equals dx, which is also an easy thing. So when you see u equals x, when you differentiate it, it just becomes du equals dx. And then for dv equals sine 3x dx, we need to integrate this to find v. So we do minus 1 over 3 because when you integrate sine into cos, it becomes minus. And then obviously you divide it by this number. So minus 1 over 3 cos 3x. Okay, so now we're going to plug these values back into our formula here, this part. We've got u, which is x, and then our v, which is here, minus 1 over 3 cos 3x, minus, and then this part. So you've got minus 1 over 3 cos 3x, that's your v, and then your du over dx is just 1, so that doesn't really come under it, and then you just remember the dx. Okay, and then we can just take the minus of 1 over 3 out of this integral, so it comes on the outside, and obviously minus and minus makes a positive. So you have plus 1 over 3 cos 3x dx, and then you're just going to integrate this side. So obviously we know that we have to divide it by 3, so 1 over 3, and then it turns into sine 3x, and you always remember to plus c. Okay, so now we can just multiply this out. We've got 1 over 3 times 1 over 3, which is 1 over 9. Remember this part from here, and then we just add c. Okay, and that's your answer for part A, which is pretty straightforward. Okay, part B. Using your answer to part A, find x squared cos 3x dx integrated. So for this question, we're basically going to do a similar sort of thing, but we're going to use our answer to part A in one of the steps. So we've got our formula here, and we've got the integration by parts formula. We find u equals x squared, which is here. And we can say that dv equals cos 3x dx. And then u differentiated is just 2x, so we end up getting du equals 2x dx. And then when we integrate dv, we get v equals 1 over 3 sine 3x. And yeah, that's our formula. It's come a bit late, but it's alright. So we can do u times v, so u times v over here, minus v times by du over dx, which is just 2x dx. And then we can take the 2 and the 1 over 3 out on the outside, so we get minus 2 over 3 sine 3x x dx, and this part stays the same. And we can just bring this x here to the front, so it just looks a bit more easy to read. Okay, so you have this, and then we remember from the last question that x sine 3x integrated gives you this, so you can just put this back into here and multiply it by minus 2 over 3. And then we can expand that out, and this is what we get. 1 over 3 x squared sine 3x plus 2 over 9 x cos 3x minus 2 over 27 sine 3x plus 0. Yeah, just make sure you remember the c as well. Okay, question 2. Use integration to find the exact value of x sine 2x integrated with the limits pi over 2 and 0. Okay, so this is our equation, and we can set our u as x and our dv as sine 2x dx, and then our u differentiated just gives 1, so we have du equals dx, and then dv integrated sine 2x, so we do minus 1 over 2 as we divide by 2, and it becomes cos 2x. And then we can just put them back into this formula here, uv minus v du over dx integrated, so uv, so that will look something like this. And obviously we've got the limits that we need to take into consideration, and then we've got minus and then v here multiplied by dx, and that is integrated with the limits. So this stays the same, and then we need to integrate this. So this divides by 2, so we get minus 1 over 4, and then this turns into sine x, so you get sine 2x. And now we can just minus these numbers, so you've got minus half cos x 2x plus half, or 1/4 sine 2x. And then we can just rearrange the x to put it in the front here, like so. And then we're going to put when x is pi over 2, which is the upper limit. Okay, so this is what it will look like, and that will be equal to pi over 4. And then when x equals 0, you do this and you get 0. So pi over 4 minus 0 is just pi over 4. Okay, question number 3. Use integration by parts to find the integral of x e to the power of x dx. Okay, so we've got a formula again, and we're going to set our u as x and our dv as e to the power of x dx. Okay, and then our u differentiated is d equals dx, obviously x just equals 1, and then our v is this integrated, and that is just the same, e to the power of x, because there's no constant in front. Okay, so now we're going to put these into the formula. You've got x times by e to the power of x, and then ex dx, nothing really changes. And then this is what you get, so you get x e to the power of x minus e to the power of x plus c, so this stays the same, but you obviously have the plus c at the end, which is just constant. B. Hence, find the integral of x squared e to the power of x. So we've got a formula again. This is our equation, and then our u is going to equal x squared, and our u differentiated equals 2x dx. And then dv equals e to the power of x, and v will just equal e to the power of x. And then we put these back into the formula. You have x squared ex minus e to the power of x 2x. And we can take the 2 out and just put it in the front here, and you have x e to the power of x. And then we remember from part A that x e to the power of x, as shown here, is equal to x e to the power of x minus ex plus c when integrated. So we can rewrite this as x squared e to the power of x minus 2 multiplied by this, and that gives you something like this. And then we can collect all the like terms and take the ex on the outside, so you have x squared minus 2x plus 2 is multiplied by e to the power of x, and then plus c. Question number 4. The diagram shows a sketch of part of the curve C with the equation y equals x ln x, where x is greater than 0. The line L here is normal to C at the point P, E. The region R, shown shaded in figure 2, is bounded by the curve, the line L, and the x-axis. Show that the exact area of R is AE squared plus B, where A and B are rational numbers to be found. Okay, so the first thing that we're going to do for this question, as we're going to use integration to possibly find the area, is we need to find where this curve crosses the x-axis. So this would be your x-intercept. We're also going to find the same for the line. We can do the curve first because that will find these points, which will be our limits for our integration. So starting with curve C first, we've got the x-intercept of the curve, which is when y equals 0, and this is the equation here, y equals x ln x. So 0 equals x ln x, well, you've got x equals 0, which is your first option, and you've got ln x, which equals 0. So imagine it's just in brackets. So when x equals 0, obviously x equals 0, but as shown in the question, it says that x is greater than 0, so this can't work. However, ln x equals 0. When does ln x equal 0? It equals 0 when x equals 1. We know that because ln 1 equals 0. So we can say that this point here is going to be equal to 1. Okay, now we need to find the x-intercept of L. But there's one caveat. We don't actually have the equation of L, so we won't be able to find out where it crosses the x-axis. However, we are told that the line L is normal to C. So when we think of normal, that basically means negative reciprocal of the gradient. So we need to find the gradient of C at this point and then do the negative gradient and find this line equation at PEE. Okay, so gradient L, we're going to find this by first working out the gradient of C at PEE. So y equals x ln x, and then dy over dx equals ln x plus 1. And then obviously using the product rule, you can find out that dy over dx equals ln x plus 1. And then at the point PEE, dy over dx equals ln e plus 1. And we know that ln e is just simply 1. And then 1 plus 1 is equal to 2. So that is your gradient for this curve. But obviously we need to find out the negative reciprocal, and that would just be minus 1 over 2. So now we know our gradient for L is minus 1 over 2. We've got the point PEE, so we've got the x and y coordinate. And now we can just plug these back into y equals mx plus c. So we've got y minus e is equal to minus half bracket x minus e, and when you expand that you get something like this. So y minus e equals minus half x plus half e, and when you add e you get y equals minus half x plus 3 over 2e. Okay, so now we've got our equation for the line and we're going to work out the x-intercept. So the x-intercept of L is when y equals 0, so we put this as 0. 0 equals minus half x plus 3 over 2e. Half x equals 3 over 2e, and then we can multiply each side by 2, and we get x on its own, which is 3e. Okay, so using this information, we now know that this point is 1, and this point is 3e. Now, this is a bigger example of the diagram, and how are we going to work out the area? Well, we can split this into 2, and that's what you need to make sure you know how to do, is how to split these sort of shaded regions, right? So you can immediately spot there's a triangle here. So we can work out this area of the triangle and this area of under the curve. So we've got A and B. So area A is the area under the curve, and we're going to use the equation of the curve and the point. So this is obviously the point 1, and this goes to E. So E would be somewhere here, right? Like that. Then we've got an upper limit as E and our lower limit as 1, and we've got x ln x dx, so we need to integrate that. To do this, we're going to use integration by parts. So we've got u equals ln x, and we've got dv is equal to x dx. So du equals 1 over x dx, and v is just x integrated, which is half x squared. And then we put that back into this equation, and we get something like this. So from this equation, you can see that half x squared times by 1 over x, well, that will just cancel out the x's, and you're going to be left with 1 over 2x, like this. And then if we integrate this, obviously we increase the power and divide by 2, so we get minus 1 over 1/4 x squared, and then this part stays the same. And we're just going to put the limits into the whole thing. So half e squared bracket ln e minus 1 over 4e squared minus, and then you put the 1 in, half 1 squared ln 1 minus 1 over 4 1 squared. Okay, so this part will just be 1 over 2e squared ln e minus 1 over 4. We know that ln 1 is equal to 0, so this part here will cancel out, and you're left with minus 1 over 4. So that will just equal a plus, so something like that, and then that turns into a plus. So you're left with 1 over 4e squared plus 1 over 4. Oh yeah, ln e is also just equal to 1. Okay, so now we're left with the area A, which is the area under a curve, and now we're going to find the triangle area, which is B. So area under curve is this given here, and then our area of a triangle B, and then we know our formula for area of a triangle, which is half times base times height, and our base is going to be from E, this point here, all the way until 3e, and 3e to e is just 2e, so our base is 2e, and then our height is just e, this part here, which is e. So half multiplied by 2e multiplied by e, obviously the half cancels out, and you're left with e times e, which gives you e squared, and then the area of the triangle B is just e squared. Now area R is just a plus b, so these two areas combined, and you're going to add them, and you get 1 over 4 e squared plus 1 over 4 plus e squared, which obviously will give you 5 over 4 e squared plus 1 over 4. And yeah, that's your area.